Hello, I am Brian, Alpha Bravo 6 Delta AB6D, and you can see in front of me here in the video is KE6MT, and I'm here to talk about Sodomate, a tool for summits on the air and parks on the air. Um, Here we are outside of Yosemite National Park, and we're climbing Parker Peak on our way to get to Coip Peak on our way to get to Kuna Peak. Kuna was a never activated SOTA summit at 13,000 feet, and it was a great day with amazing views. And then we had to retrace our steps to get back to base camp down at the bottom there. So let's talk about Sodomate. This is based on a presentation I gave at Pacificon a couple of months ago, and talks about how all of these recent technologies, software-defined radio and FT8 and a number of other technologies, how we can combine all of these things into this new tool called Sodomate. And it's spelled funny because it's actually a phone number, and that's the 7 digits of the phone number is Sotamate. And I didn't have an E to make the spelling correct with the telephone number. So our agenda, I'm going to go really quickly about what SOTA and POTA is. I think many people are somewhat familiar with it, even if you haven't done it before. So I'm going to do that real quick, and then we're going to get into what the problem is that Sodomate is trying to solve and some technical information about how it solves it. All right, for those who don't already know, SOTA is Summits on the Air, and it combines amateur radio with climbing mountains into a fun awards-based activity. And Outside Magazine said it's like biathlon, but for geeks, which is a great way to describe it. So why do we do SOTA? Well, it's a really inclusive activity that has something for people of all levels of ability. For those who want it, you certainly can get a lot of exercise out of the sport. It can also be a great social activity. Bring your friends along. There are new places to find that have these amazing views, places you probably wouldn't go to on your own because these summits are algorithmically defined. You'll often find surprises when you're out in the wilderness, like this fox on the side of the road. And you can get into all sorts of new tools and technologies, especially in the QRP world, ultra light, ultra small, ultra efficient technology out there. And for those of you who are into emergency communications, this is a way to get some seriously off-grid practice. And while the SOTA official organization clearly states that this is not a competition, there are points and there is a leaderboard, and that allows you to set personal goals to stay motivated. So you can compete with yourself and others if you're into that. And don't think of it as a mountain. Think of it as a 10,000 foot high antenna mast. And you'd be amazed at the range that you can get with a $40 handheld HT radio when you're at 10,000 feet. It is really amazing. Of course, there's a lot to learn. And there's a lot to learn not just about QRP and the technology and the radio and the methods, but you also get to learn about the natural world and about yourself. All right, enough about why to do SOTA. For those of you who don't know, it's organized in a hierarchical way. We have these things called associations, which are either countries or parts of countries, and they're divided into regions, like the Northern Sierra, and those are divided into the individual summits, such as Red Lake Peak. And they all come up with a code like this. And so again, I'm not going to go into the details. You can read about the rules and stuff on your own on the websites. All the information's out there. But you have these regions in the state I live in. They're all overlapping and very confusing, and that has some implications later. These peaks that are in these regions and in these associations, many peaks that are out there don't qualify to be a SOTA peak. The peaks are selected by a prominence algorithm, and it's not based on practicality. In fact, many SOTA peaks cannot be activated due to private property and other rule and regulations. So not every peak qualifies, and the ones that do, you may not be able to activate. Now, points are based on the peak's height, and it goes from 1 to 10 points. Now, some special peaks have a 3-point bonus during difficult winter or sometimes even difficult summer months, like around Death Valley. But the surprising thing is that the point scales differ across associations. I, for example, have recently done a 6,000-foot peak in Sneakers in Tennessee and gotten a 10 points plus a 3-point winter bonus for 13 points. While in California, if I did a similar 6,000-foot peak in snowshoes in deep, sloppy, slushy conditions, which are just terrible, I might only get 6 points for the exact same height for far more effort. And I told you that the sport was inclusive, and you can see that a lot of people are using just FM handheld radios, while other people are using HF voice. And still more, very popular is CW, Morse code, because the radios for CW are so lightweight and efficient that you kind of have a built-in motivation to pick up CW if you're in this sport. I'm still learning CW myself, mainly because I don't want to carry all this equipment. And you get much better range, too. Now, there are two main roles in SOTA. First, you have the activators who operate the radio on top of a SOTA peak. They're the ones that assume the leadership role due to safety and hardship. You know, they had to hike the way out there to 13,000 feet or whatever, and they get the points based on the peak's height, as we mentioned before. And back at home are the chasers. Chasers have the challenge of finding an activator on air, and they take the direction from the activators, who are the leader, and try and help them. Now, the chasers get their points also based on the activator's peak height. And that creates a really nice incentive to help the activators who've climbed the harder peaks. Some peaks you can practically drive up to. They may only be a couple hundred feet. No big deal, 1 point, and may not be a lot of effort. But for those of us who go way out there and make a lot of effort, we want there to be that incentive. Now, the most exciting activations are summit to summit. This is where an activator on one peak makes a contact with an activator on another peak. And summit to summit traffic always gets priority since both parties are disadvantaged. They both get points for activating and chasing at the same time, and there's special awards for that. Again, I'm not going to go into all the rules because you can read it online, Google it. And also, you know, safety is really, really important when you do this. If you do the sport enough, you're going to run into some issues. And so you need to do your research and you have to do your preparation well. I'm not going to go into it, but just telling you, you need to do it. And if you don't believe me, you know, for those who don't follow it, I've almost won the Ben Franklin and the Darwin Award simultaneously when I read the weather report that said 10% chance of rain, and I thought, oh, it's not going to rain. So I wasn't fully prepared for the fact that a lightning storm came in out of nowhere. And if you do 10 peaks and you have 10% chance of rain, you would expect that one of those times it would happen, and it did. Thankfully, I was still okay. All right. When you're in the mountain, on a mountain in the cold, you don't have all day to call CQ waiting for a SOTA chaser to find you. And there are these websites that help chasers find you on air. And you can file an alert before you plan your trip, and that is your plan that tells chasers about your future activations. But when you're actually on a peak, you send out a spot. A spot is your announcement of something that's happening right now. So alerts are a plan, spots are right now. All right, let's do even quicker parks on the air. Parks on the air is very similar to summits on the air. You know, POTA allows you to operate anywhere within a qualifying park. So you don't have to be just on a peak. You can be in something, you know, Yellowstone National Park. It could be like almost anywhere. And so this can be national parks, state parks, and even the 2,000-mile-long Appalachian Trail. While SOTA and POTA are organized similarly, there are some differences in terminology, and you can read about this stuff on the web. A big difference is in the awards. In SOTA, height is the key, but in POTA, it's often about how many parks you can activate simultaneously due to overlapping boundaries. You know, SOTA mostly deals with QRP gear, while POTA has some of everything. Many SOTA peaks are inside POTA parks, and so you can do simultaneous activations there. If you look at the pictures here, It's pretty clear which one is SOTA and which one is POTA. If you look comfortable, it's going to be POTA. As I like to, well, I won't say my joke because it's not fair. You can see I have a SOTA slant. All right, so what is the big problem that Sodomate is here to solve? Well, if you've made it to the peak and the wind is picking up and the sun is going down, how do you help chasers find you? You need to get spotted. And there are several ways. If you have cell data service, you can use an app like SOTAGoat to self-spot. If you have weak cell service where cellular data might not be available, but you might still be able to get cellular SMS to work, then you can use one of the SMS gateways for both SOTA and POTA to spot you. Now, if you don't have any cell service whatsoever, you can use a VHF radio and use the APRS gateway to spot you. But since VHF is essentially line of sight, plus, I don't know, 30%, it doesn't always work. The fourth way is with a satellite messaging device, but this is an investment and requires an ongoing subscription. And it has its own problems as well, especially with some of the gateways that don't allow the satellite telemetry and the fact that Garmin, in fact, just has a policy now of blocking virtual phone numbers that a lot of the automated attendants use. So it's not guaranteed to work. The fifth way is to use Morse code and the reverse beacon network and a gateway called RBNhole specifically for SOTA. This works great, but you have to know CW and you have to remember to post an alert before your trip. And if we have time, we can talk about this later. All right, finally, there is the JS8 call gateway. It is super cool, but it requires that you bring a whole bunch of equipment with you that is fine for POTA, but not so cool for SOTA when you have to carry all this stuff up a peak. I mean, things like you need some form of computer, maybe a screen. You need a some way to power that computer or Raspberry Pi and some kind of converter, and you need audio cables and interfaces and sometimes GPS dongles. So it's a lot. All right, so let's talk about the next way, the seventh way of self-spotting, and that's a new solution called Sodomate. Sodomate is a tool that currently has a bunch of these functions. The first ones on the top there are about sending one-way commands over HF radio to a server and having that server either spot you or post an alert or send SMS messages on your behalf. Then on the bottom, you can also use these two-way commands. So if you do have a Garmin InReach or a Zoleo, or if you do have cell service for SMS or email, then you can do a number of things. And this slide is out of date. I'll have to update that. Ah, there it is. All of these are now, the slide is up to date. Look at that. All of these have been implemented here on the bottom. These are the new functions that were added in the last couple weeks. All right, let's get into it. So Sodomate integrates several different technologies. You probably know about the FT8 digital mode. It's great for sending short messages long distances at low power. But FT8 is not a conversational mode. It's only designed to send a basic call sign exchange and not a bunch of SOTA peak or POTA park information. And as we mentioned before, it requires a lot of equipment, so it's not practical at 13,000 feet. But recently, a developer ported FT8 onto the iPhone, and another developer in India ported FT8 onto Android. And I had early access to the iPhone app because the developer, Ron Nicholson, is in my local club. And in fact, he's an interesting guy because his name is engraved inside the plastic case of the original Macintosh and the Amiga 1000. He was on both teams and is written up in the Computer History Museum and so on. So an interesting guy with an interesting past that's had an impact on the industry. All right, I started experimenting with this portable FT8 with a simple cable, and it worked great for sending and receiving FT8 over the radio. But then later I found I didn't even need a cable if I played the audio from the iPhone speaker directly into the radio's microphone and vice versa. I started thinking about using portable FT8 to self-spot. All the puzzle pieces seemed to be there. We had mobile FT8, for example, and I knew that there were these hundreds of software-defined radios that are out in the world monitoring the airwaves 24/7. This is my home software-defined radio software, which is listening to 4 bands at the same time for FT8 signals. And it's also listening on 4 bands for PSK31 signals on those frequencies, all at the same time with just a single radio. We call this skimming. So with software-defined radio and the right kind of hardware, you can have one radio that's just a couple $100 that is literally listening to, in my case, 8 different frequency regions simultaneously for every conversation that's going on from every operator that I can hear. And it reports all that information, all of those call signs that it's hearing, it reports them into PSK Reporter. These skimmers go into this central database, and it's a great tool that lets you see where your signal is being received in real time. Now for self-spotting, I envisioned this workflow. From left to right, we should use our HF radio to send the special FT8 message from a peak, which monitoring skimmers would pick up and report to PSK Reporter. My Sodomate server would filter all these zillions of reception reports that are coming in, and it's about 400 reception reports per second. And the server would look for special messages that are intended for Sodomate. And when a match is found, Sodomate would perform a command, such as posting a SOTA Spot or a POTA Spot or sending an SMS message to my wife telling her I'm okay. That was the idea. Much later, I actually got all of this workflow to actually work. And let's hear this video from one of my beta testers, Chris, N1CLC, using an earlier version of Sodomate on his iPhone in the field to self-spot. Okay, so first he selects the Summit ID. This is the Sodomate app. He selects the Summit ID that he's operating from. Next, he selects his desired mode and band that he wants to work. Then he selects a specific frequency that he's going to operate within that band. And then from those choices, Sodomate has computed an FT8 message that encodes all of that information into that call sign with a suffix. And this is what gets transmitted. So finally, Chris clicks the launch button at the bottom here, and that will send this FT8 message over to the other iPhone app, the one from Ron Nicholson, and Ron's app will send that FT8 transmission over the air. So Sodomate computes the message, and Ron's program transmits the message over the air. So rather than get into how it all works, we're going to fast forward to the very end of the movie and see it in operation, and then we're going to back up and see how it all works behind the scenes.
N1CLC, my call sign, /2 Hotel Victor Lima. Let's try that. All right, I'm spotted. I didn't notice it already came through. And so let's see if we can't make some contacts here. Kind of slim pickings this morning on sideband. I'm glad I got spotted. This FT8 worked perfectly, just as advertised. I think my spot went out the first time I sent the FT8 message. This is really, really cool. We're going to try it again for CW this time, and we'll set up there. I'm going to do it twice, so we're going to transmit our FT8 signal twice, and as you can see here, it's 1 Yankee Bravo Delta. All right. So now I'm going to jump down to 7058, tune up, and we're ready to go. Let's see if I got spotted.
And he was spotted, as you can see there. So pretty easy to use. There's a lot to read about how you prevent splatter on the band, how you get your signal to noise ratio when you're not using a cable to connect the phone into your radio's microphone. So there's some thought and some testing that's gone into that. And there's on the website, you want to read about how to do it cable free. And for those of us who use it a lot, cable free is the way to go because that way you don't have to deal with a bunch of Vox settings and other tricky stuff that you have to do when you use the cable. All right, so that was the idea, and you can see that it works, but I didn't know what I didn't know when I was building this service. And it's actually quite amazing that it works, and there were a lot of almost miracles and lucky accidents, including two completely unintended features of two different programs that the authors didn't even know that they had in their software that they had written, that this whole thing depends on. So we had some secret APIs that were found and the help of many different people along the way. All right, so my original idea was to use FT8 to send a message to myself rather than call CQ. And by using my call sign as both the from and the to, I wouldn't be bothering anybody else since I'm not talking to them. I'm not calling CQ, and I'd be talking to my Sodomate server. The idea was to encode the information in that call sign suffix as shown here. And it worked. I could see these messages when I tested it show up in PSK Reporter after transmitting them. So pretty happy in the beginning. Now, while it worked, it wasn't what it seemed to be. You see, FT8 is designed to send as little data as possible to make a contact. Joe Taylor's got these documents that explain that the 28 bits allocated for a call sign in his messages in FT8, those 28 bits are not enough to encode a call sign with a suffix. To send a suffix or a prefix requires 58 bits. So FT8 standard messages only have 28 bits available, and there's no room for a suffix. So my solution can't possibly work, but we know it did. So what's going on here? I got very excited that a more recent feature of FT8 allocates a full 58 bits that are needed to encode the suffix. Perfect. Looks like we're done here. But later I learned from Philip, the inventor of PSK Reporter, that the WSJTX software only sends reception reports to PSK Reporter for CQ messages. And CQ messages, the way they're formatted, only use the 28-bit form and not the 58-bit form that it can allow for a suffix. So in other words, you can send a suffix, but no one in the skimmers will be there to hear it. So it can't possibly work, but we already know that it does. So what's going on here? Well, remember that in my original testing, I had actually sent this message with a suffix, and it showed up in PSK Reporter. After several discussions with Ron, we figured it out. The FT8 iPhone app that he wrote had an unintended feature with how messages are parsed. Since my message wasn't valid as a 28-bit message, his software automatically ended up encoding it as a 71-bit free text message, which allows 13 random alphanumeric characters to be sent. So in other words, my message was no longer a call sign with a suffix. It was really just a set of random letters in a free text message that didn't represent a call sign or suffix to the computer, only to us humans looking at the message. And that is pretty interesting. So our message can go out, but again, how does it get received when it's not being recognized as a call sign? Well, when I was looking at my reception reports coming in from PSK Reporter, I started to notice something really funny about the decoder column, the software that was being used to decode the messages that were getting through. It turns out that instead of WSJTX or any of the other popular software-defined radios out there, the software that was receiving my messages was always Spark SDR. And that was the key. It turns out that the Spark SDR software works differently from every other FT8 program on the market. It has an unintended feature where it doesn't parse call signs based on the bit fields as defined in the FT8 spec, but rather it parses out the call signs after the WSJTX decoding has happened. This late parsing instead of in-place parsing allows the software to extract call signs no matter how they are encoded, including call signs inside of the free text field. It also sends these reports to PSK Reporter even when they're not in a CQ message, just like all the other software does. So we've got two unintended features working together in the Spark SDR software and one unintended feature in the iPhone FT8 app. So three miracles that allow this to work. Now, as I said, FT8 free text can have a maximum of 13 characters. And for the Spark SDR parser to find a call sign, it has to be in a certain format. There needs to be some text in the front, like the letter S here. It has to be followed by a white space character. And then it has to be followed by a legal call sign, like the blue, and then followed by an optional suffix of up to 4 characters. Now, since call signs can have up to 6 characters internationally, you can see the whole thing fits exactly into 13 spaces. This is like the 5th miracle now, that the FT8 free text is exactly the right number of characters needed to get our 4-character suffix through the system. Beautiful. All right, the next roadblock was that PSK Reporter's APIs don't allow wildcards. So while we can send our messages, while skimmers can receive them and send them to PSK Reporter, and while you can call a PSK Reporter API to query to see if a particular message was received, that does work, but you can't use a wildcard. And that means that if I wanted to get any reception report for my call sign with any suffix, I can't express give me any suffix. I have to have the software make an API call for the specific suffix that I want it to look up. Well, that's not going to work, especially when I've got lots of people using Sodomate, and they could be using one of millions of possible suffixes. So this was the next miracle, was that Philip, the inventor of PSK Reporter, liked my project idea enough that he gave me a special API with a direct feed of his raw database stream. And he doesn't do this lightly because he gets zillions of requests for this. And his databases have to deal with 400 reception reports per second, and he can't be sending this data out in a separate fork to lots of different services out there. It would just overload his databases and cost him more money to make it resilient. So it was very fortunate that Philip gave me that access. Nowadays, there's an MQTT repeater that you can connect to get access to this kind of data, and that's the more official way. But again, that's a multi-hop, and I have a more direct feed. All right, awesome. We now have a way to get an FT8 message with a 4-character suffix from our HF radio in the field to Sodomate for decoding and command execution. So what kind of information can we encode into a 4-character suffix? Well, at first glance, it seems like we've got these 26 letters and 10 numbers for a total of 36 combinations per character. So 36 to the 4th power is about 1.6 million combinations. However, if you're clever, you can overflow and use a space in some of the character positions. So we really have about 1.7 million combinations available, and that works out to be about 20.7 bits of data, almost 21 bits of data. Now Rex, KE6MT, he pointed out that many of the suffixes I was generating are not legal because they indicate that an operator is transmitting from a remote location. So for example, my call sign with /4 means that I'm operating in Tennessee, or with /DR means that I'm operating in Germany, and so on. So we can't use locators in our suffixes. And I've had experts tell me that all suffixes are locators. And so this looked like yet another dead end for Sodomate, that I couldn't do it legally. And that's where the next miracle comes in. You see, the FCC rules discuss the difference between locators and indicators. The FCC allows an operator to use a self-assigned, and this is important, self-assigned indicator as long as it doesn't conflict with any locator globally. So our 4-character suffix is just a self-assigned indicator as long as it doesn't conflict. But figuring out what is a conflict, what is a locator, isn't so easy. I spent a lot of time reviewing all of these documents and a lot of code. And some of the regulations are potentially self-conflicting, and there's long discussions and debates about how the rules are potentially actually in conflict with themselves. But there is kind of a consensus or a de facto standard of what creates a locator versus an indicator. And after studying all this for months, I was back in business. But in that valid list of indicators, there are suffixes like help or crap, and we don't want to transmit these Sodomate commands that look like a human message. So another task was to go through and build a giant table of 4-character English words or less, and a list of international bad words, swear words that I got from Google, which that publishes a list of international bad words, and remove these from the list of valid suffixes as well. So after a process I called defragmentation, I had a table of about 1 million clean 4-character suffix indicators. And that works out to be about 19.9 bits of data that we can encode. 19.9 bits isn't a lot of data. So I considered using the FT8 even odd time window as an extra bit. And I experimented with using the FT8 audio frequency offset as a way to encode more bits. Okay, which frequency are you actually sending your FT8 audio tones on? Can be bucketized and turned into some additional bits. But no matter how I tried, I didn't see an easy way to get more than about 26 bits worth of data. So then the question is, how many bits do we need to encode all this information? And it turns out that we need about 47 bits to encode all the possible SOTA peaks and POTA parks, plus all the modes and frequencies that we might want to use. So we need 47 bits, and we only have 26 bits. So this isn't going to work. And that was another point of depression in this project that went on and on and on. So I then started to use probability to see if I could encode maybe the most probable parks and the most probable modes and the most probable peaks into my 26 bits. And it still wasn't going to fit. So probability wasn't going to help me. So the solution was to have each operator predefine their own personal list of summits and parks that they intend to activate within a year or two. Their own personal set of modes and frequencies that they might want to use for their equipment, and that we would build suffix tables specific to each operator. Each operator would have their own 1 million suffix combinations tailored to them, and that is how you can fit into 26 bits. So here is a website that I built to allow operators to build their personalized Sodomate configuration. Let's walk through how you use Sodomate for real. You start off on a desktop computer. It's a lot easier to do this on a desktop, but everything I'm showing can be done on a mobile phone if you're out in the field and you want to make a change. So it works both ways. So first you come in, you register an account, and I'm going to say it again slowly here. You have to use your Callsign as your username when you register for an account on the site. That's key. Otherwise, all this other stuff doesn't work. After you register, click the preparation button, and then the SOTA regions button if you are a SOTA operator. And here you define your personal list of your home SOTA regions that you operate in. So we're customizing this to our own situation. So we're going to click and we're going to search the worldwide database of regions, and I'm going to type in, let's say, Whiskey 6 stroke November Sierra, and I'm going to get the Northern Sierra region. It's in the database there, and I just select it out of the list, which I searched on. And when I'm done adding each of these regions that I use in my home area, for me, it's the Sierras and around the Bay Area and part of Tahoe region in Nevada. Those are my regions. I build up the table here. Now the notes column on the right, the software doesn't use that. That notes is really just notes to yourself. So you can leave that blank if you want. If you fill it in, it will show up when you're in the mobile app, and you can have some notes to yourself if you need them. All right, so and again, coming back to this, I want to point out you only need to do this once, right? You're not listing a set of peaks that you're going to activate. It's not like what you're going to do this weekend. No, you're listing entire regions of the world that might have hundreds and hundreds of parks in these regions. And so you generally do this pre-configuration once, maybe per year or per decade, and get these tables built up. And then it becomes easier after that one-time setup. Now here we go back to the menu and we do the same thing for POTA as we did for SOTA. So here I've added US, California, and Nevada as my POTA locations where I have parks that I'm planning to activate. Okay. All right, next I select the frequencies and modes menu, and here is where I define all the bands and all the modes and the frequencies that I might want to use when I'm on a peak or in a park. So let's zoom in here. And in the first row, you can see that I am defining a set of single sideband frequencies that start at 7.178 megahertz. And it's going to increase in 1 kilohertz steps for 120 steps. So it gives me a range of frequencies that basically are 1 kilohertz increments within the single sideband voice part that the general class licensees are allowed to use. I'm extra class licensed, but I like to transmit where the generals can talk. And so I've defined those 120 frequencies I get to choose from when I'm in the field. All right. And then if you look down towards the bottom, you can see that I've defined 4 FM channels, starting with the national calling frequency of 146.520 for 4 steps, incrementing at 15 kilohertz per step. And there's some other special commands in there, especially for CW operators. If you're the alert CW up there at the top, that's intended to tickle RBNhole. And that's more for advanced users who need the system to file an alert on their behalf rather than a spot. And maybe we can talk about that later. All right, the next thing that I can do is define a table of messaging commands. Okay, so I'm going to click that in the menu, and here you define a set of predefined one-way SMS messages that you can have sent when you're in the field. So for example, you might have a message that tells your spouse that you made it okay to the summit, or that you're behind schedule, or that you need help. These SMS messages, of course, are only one way. The system can't respond back. But when you're in the field, you can select any one of these predefined messages that you've programmed. And it gets encoded into one of those 4-character call sign suffixes. Okay. Email is highlighted in red there because that's not yet implemented in this part of the software. It's just SMS. All right. Now that we've done all this preparation and we've defined our peaks and our parks and our modes and our frequencies and our messages, when you've done all that, you come back to the preparation page again and you scroll to the very bottom of the page and you're going to see a summary of your entire configuration, everything you've done. At the top is your list of SOTA regions. You've got your list of POTA locations. You see your frequencies and modes listed there. But here's where it's important, the bottom stuff. This is a computation of all permutations of every peak and every park multiplied by every frequency and mode step. And if you multiply all those possible combinations out, the green box is the total number of possible call sign suffix combinations that can encode all of this data. And you need it to be less than 1 million. And if it is less than 1 million, the box turns green. And if it's more than 1 million, the box turns an angry red, telling you that you have defined too many combinations for the system to work, and you're going to have to either remove some frequency steps or remove some parks or remove some regions from your SOTA to get it under 1 million possible combinations. All right? So once you get a green box, you're done on the desktop computer, and now you move over to your mobile phone. But before we go to the phone, let's take a look at this configuration screen. Everything that you've just defined, that configuration, gets encoded into this, what I call a blob of text, this configuration blob. And this gibberish is just compressed data about everything that you've taught the system about your configuration assigned to your call sign. And so every letter in that thing counts when you copy and paste it. So this is the data that we're going to paste into our mobile phone app. Okay. Now the important thing that you have to understand is if you ever change anything about your configuration on the website, you must load a new configuration into the mobile app. The mobile app is designed to work offline in the field with no internet access. It doesn't know that you've changed your configuration. That app is really an offline app. In the future, I might make it sense if it's online and auto sync and everything, but for now, it's designed to be a set once and forget kind of app. So if you do change your configuration, you change a frequency, you change a comment, even if you change a single letter in an SMS message to your spouse, that completely changes all of the configuration, the way this data is compressed. And so if you make any change on the website, you must reload this configuration into the mobile app so that the server and your mobile app are always in sync with each other and that they always agree letter for letter on what your configuration is. Okay, let's see how you set up the mobile app. We've done everything on the desktop computer to set up our configuration. Let's get the configuration loaded into Sodomate. You can see the app icon there in the upper left. Let's launch the app. And we come in and we go to step 1, Sodomate preparation. All I'm showing you here, normally you wouldn't do this step 1 on your phone. You'd normally do this on a desktop computer. But what I'm showing is that everything we did on the desktop computer, it's just a web page. So of course you can do it on a phone as well. So the same menu there, it's just laid out a little bit differently. There's our green box with the less than 1 million combinations. You can see your summary and so on. All right. Now we want to go back to step 2 in the setup app of Sodomate. Step 2 is to load in a configuration. So there's that configuration screen. We're going to click the copy to clipboard button there. That's going to copy that configuration blob of text. Step 3, we're going to paste that configuration blob into the app. So again, it's meant for offline use. And the neat thing about why did I do it this way instead of just automatically loading it is that configuration blob of text. If you're in the field and let's say you have 3 operators and you all want to share one mobile device, you can store those configuration blobs for each call sign in your iPhone's Notes app. So have an offline app that doesn't require internet access like iPhone's Notes or Android has a Notes app. And you can just paste that configuration blob for friend number 1, friend number 2, friend number 3, and you can have all of these configuration blobs. And in the field, if your friend wants to send out a self-spot, they can load their configuration into your app and send the FT8 message. And then when you want a self-spot, you'd load your configuration. So all this can be done offline with no internet access. Now at the bottom of the screen there, you can see the loaded configuration. That blob of text got decoded, decompressed, and it's giving you some statistics on what got loaded, a bunch of information there. And you can again see that there's about 643,000 combinations of suffixes that your configuration defined. And here's just an example of how I've got these configuration blobs for different users. I've got Rick and I've got Eric and I've got their blobs loaded up into my app. So I can swap them in the field. All right. Next, after we've loaded this configuration, let's go use the app. So we are going to, on the bottom there, you can see the bottom tabs. We're going to click on that first tab that we're going to do a SOTA Spot. We want to spot ourselves. So I go to the SOTA Spot screen. I select a, oh no, I'm doing POTA here. I'm selecting a location for POTA and a park ID for POTA, and I selected a mode and a band and a specific frequency, and you could see that the app has computed a suffix for me, and it works the same way for SOTA as well. All right, so how does this actually get encoded? How do these suffixes work? Well, if you think when we built our configuration, we defined a bunch of SOTA regions. Let's say region A in this example, and let's say region A has 4 summits in it, 1 through 4. That defines a code that goes from 0 to 3. That's 4 possible combinations. Now, we probably didn't just add one region, we probably added multiple regions. So here I've got region B, region C, and I probably have some POTA parks. So I have POTA location 1, POTA location 2, and within those locations I have parks 1 through 3 and parks 1 and 2. So when I add all these regions with summits for each region and parks with parks for each location, here I've got 15 combinations numbered 0 to 14. Okay. Now, that is all defined for just one frequency and one mode, one frequency step, one mode step. but I defined a whole bunch of frequencies and modes, and that's the vertical axis. So I just repeat my exact same regions and summits and POTA locations and parks, and I just stack them up and make a multiplication table here where I can multiply any frequency and mode times any region or park, and that gets encoded into a number that goes from 0 to 98, which means I have 99 possible combinations here. Now, I also had those text messages that I can send to my spouse. So let's imagine I had predefined 6 messages, and I number those 1 through 6. So that gives me up to 105 possible combinations that go from 0 to 104 as their number. And remember that this entire table is specific to one user, one call sign. And that other users with other call signs, they have their configurations as well. So the server is keeping track of everyone's configuration and knows how to encode and decode all of these suffixes for all these different users. So if we're one user and we're on a peak and we pick a specific frequency with a specific summit in a specific region, the yellow circle there is one specific summit at one specific frequency and mode, that turns into a number out of our 0 to 104 table. But remember, we're not allowed to send locators and swear words and things like that as our suffix. So we have an expander table that takes that linear table and expands it into the code space that goes from 0 to 1.7 million suffixes so that it avoids the red ones that are illegal suffixes. So we expand that out, and that then goes from being a number and gets converted into a multi-character with space overflows character generator that generates the suffix. Okay? That's how the software figures out what to send. And you can see how it's critical that the server and the mobile phone are in complete agreement as to what that configuration is, because even a single letter change can change how all this mapping works. Now, what the server does is it gets a reception report from the skimmers, from PSK Reporter, and it gets a call sign and it gets the suffix. So it looks up that call sign in the database and it figures out which user, if they happen to be a Sodomate user, what their configuration is. And there's a little trick here, which is the timestamp. When you visit that configuration page on the website, the server is remembering when you grabbed the configuration, because when you loaded your configuration, let's say a year ago, into your mobile app, it's possible that the SOTA organization has added a new peak. There, a couple times a year, they add and remove and update the peak database. And if they add a peak to region C, and when you loaded your mobile phone, you didn't have that peak in your configuration, now the server and your mobile phone wouldn't be in sync as to what the peak sequencing is. And that's where the timestamp comes in. So when you grab your configuration blob, the server remembers when you grabbed that blob, and it knows how to go back in history and look at what the peak database was on that date. Okay, and that's the way the server and your mobile phone always stay in sync. And so the moral of the story is here, don't visit that on the website. Don't just randomly go to that configuration blob page and visit it unless you're actually going to load that configuration blob into the mobile app. There's no reason for you to go to that page other than to load your configuration into the mobile app. Because if you do visit that page, you're resetting the timestamp, and you may not want it to do that. All right, let's see it in action here. So we saw Chris do it. I'm going to show you again and give you a couple more tips. So I'm going to launch the app here. I've selected, I'm going to send an SMS message to myself, so I've selected a test message. It generated the suffix. I use the AB switch to go from my single sideband to the FT8 frequency, and I can hear all the other stations. So I don't need to synchronize my clock so much as to when to hit push to talk. I could just listen to when the other stations finish. They finished, I hit push to talk. And now my phone starts transmitting. And what I want you to notice on the display here is that on this Elecraft radio, I have 4 bars of ALC. And this is what I write up on the website on the FAQ page is how do you get your signal to noise ratio just right so that you don't create splatter and you don't pick up background wind and birds chirping and other things going on around you when you're not using a cable. And there's a whole method to this to improve that signal to noise ratio without getting splatter. And a lot of it is tied to watching your ALC on your radio, the automatic level control. On the Elecraft radios, 4 bars of ALC means no ALC is being applied. It's the 5th bar and above, which is when your radio is doing ALC. So on this particular radio, you want to target 4 bars. And you can see while I'm operating, I'm ever so slightly moving the speaker of the iPhone closer or farther from the microphone on the radio to keep that right at 4 bars. Now, if you have a Yaesu radio, those radios, 0 bars means 0 ALC, and any bars shown means that you are playing ALC. So Elecraft radios and Yaesu radios are a little different. There, you can see I'm hitting 3 or 4 bars of ALC, which is perfect. Every once in a while, I hit a 5th bar, and then I back off. And that's how I keep my splatter down. All right, so I've sent my message. I hit my AB button on the radio to resume operations, and then it takes several minutes, and you see that Sodomate has sent an SMS message to my phone, and I can see it on the watch there, and there's my SMS message going through. Now, why did it take 2 minutes in this example? And in fact, it can take up to 6 minutes. And the reason for that is not that the speed of light is slow with Sodomate. Remember, radio waves are the speed of light. So as soon as you send the message, it's been received by those skimmers. The issue is that the skimmers have to follow the PSK reporter protocol. And that protocol requires that they batch all their reception reports for 5 minutes before sending them into PSK reporter. Now, while FT8 is synchronized against the atomic clocks as to when to send, PSK reporter skimmers, the skimmers' reception reports are not synchronized to each other. So they're all queuing up 5 minutes worth of reception reports, and when after 5 minutes they send all of their reception reports up to PSK reporter. But because they're not synchronized, on average, you generally have to wait about 2.5 minutes if you've got a couple receivers that hear you. That's what I found. But it can, if only one receiver hears you and they heard you just after they sent a reception report to PSK reporter, it means that your message may not get sent through the system for another 5 minutes. And then once it gets to PSK reporter, there's another 10 seconds before my server gets it, and then there's processing, and then there's another time that the SOTA site sits on it, and then there's the alerting apps like SOTAgoat and stuff that tell people that a new spot has been heard. They poll sometimes at once a minute intervals. So in other words, it can take up to a maximum of 6 minutes for the message to get through, but on average it's about 2 to 3 minutes. All right. If we now go back to the website after we've activated our peak, we get home and we want to do a little debugging or something, we can go to the main website and click on the activity button. And that screen shows you a bunch of reception reports. At the top, you see anything that's your own reception report. And here you could see that many of our messages have duplicates, meaning that multiple people heard us. And that's another thing that I recommend you do. When you send your Sodomate FT8 messages, I recommend you send the message 3 times. Even when your reception report shows that you had a strong signal into a skimmer, I send 3 times, and maybe it gets received 1 of the 3 times or 2 of the 3 times. Rarely does it get received all 3 of the 3 times, even when my signal report was strong. So if you only send your message once, even if you should be getting through, I don't know if it's QSB or what the issue is, but you have much more certainty of getting through if you send your message multiple times. Now, there's one other issue that comes up, that the FCC has some other rules that say that digital codes, and of course the Sodomate messages are digital codes, must not be transmitted for the purpose of obscuring meaning of the communication. Well, my suffix is have a lot of meaning in them, but it's pretty obscure what that meaning is. And so this can run me afoul of these FCC rules. But if you read further, there's a way around this. Think of FT8. The FT8 has forward error correction and all sorts of compression and encoding. So FT8 messages, the bit pattern that's sent over the air is highly, highly obscuring. And the way that FT8 gets around that is they publish their protocol. They've opened that up so that anybody can decode that. And so how do I do that with Sodomate? Is effectively I'm publishing the protocol, but more importantly, I publish the decoding of all these reception reports. So all these encoded messages I decode and put on the web publicly for anyone to see, even without an account worldwide. And so these messages do not have the intent of obscuring their meaning because I'm sharing what the meaning is. You'll also see in this screenshot that you don't have to use FT8. Any path that gets your call sign and suffix into PSK reporter will work. And you can see I have some operators that use PSK31. And this is really interesting because the Elecraft radios have PSK31 support built into them, meaning you don't even need the iPhone anymore. You don't even need an Android phone. You can just use the radio to send these messages directly. I don't recommend it, and the reason why I don't is that there are so few PSK31 receiving stations worldwide. In fact, on the West Coast, I think my home station is the only active PSK skimmer that's listening. And I have a terrible antenna, and I have a neighbor that puts out about S9 LED noise from his lighting system. So my receiver is pretty much deaf. And that's why I don't recommend you use PSK31. But if you want to experiment with it, you can see other people are, and these are the purists who really don't bring any other equipment with them except their radio. There are people using these other modes. And you can see here that we have a user who posted an alert. This is a CW operator who is not really trying to self-spot themselves with Sodomate. They want to use RBNhole to do automatic spotting of their CW messages, but they need a way to tickle RBNhole of their whereabouts, and they do that with a SOTA Alert. So you can use Sodomate to post a SOTA Alert if you're a CW operator. That's pretty cool. Okay, that was it for all of the one-way commands that you can do with Sodomate, using HF to send a SOTA Spot, a POTA Spot, a SOTA Alert, or an SMS message to a friend. But when you do have a two-way device like a Garmin InReach satellite device or SMS service or email, there's all these other commands that you can use. And I'm not going to go into a lot of detail here, but I'll just show you some examples. Here's the phone number 1601 SOTA-mate. 768-2628 is the phone number, as you can see there. That just spells out Sodomate. On some devices, you can actually, instead of typing digits, you could just type in the letters. And so 601 Sodomate. And here I'm going to interact with it, where I'm going to ask it to send me a list of commands. So I just tell it hi because I can't remember what the syntax is, and it comes back and says, hey, these are the commands you get to use. And this video was done a while ago, and the command list is a lot longer than that now. And I'm telling it, hey, I'm interested in SOTA spots that are happening right now. And this is great if I want summit to summit, right? So if I'm on a peak and I want to know what other frequencies other activators are on, I can type in this spots command. And I could say, well, maybe I'm only interested in single sideband spots. I want to do voice. And just give me 3 of them. And I want it in short format. Now, short is when you have, let's say, a Garmin InReach and you're doing this. You don't have a very big screen, and they charge you based on the number of bytes that you send. So the short form shrinks everything down, gets rid of the verbose version of this stuff. Anyway, you can use this through an email or SMS, and there's even a special Garmin InReach aware service. You can read about it on the web. It does a tremendous amount of stuff. You can get weather reports specific to a peak and specific to the altitude of the peak. You can get information on another call sign, how active they are in POTA and SOTA. You can get peak information. It has all sorts of stuff that it can tell you by sending it these messages in this two-way thing. Again, there's special support for Garmin. and so on and so forth. So summit info, call info, weather info, spots, alerts, you name it. It's two directional. It works for SOTA and POTA, and even the slide is not up to date. You can post spots and do a number of these things for both SOTA and POTA. All right. That's the end. And I'll just say, again, there's a lot more on the website. Make sure you read the FAQ before you use it. Make sure you read the two-way information on the website as well. Maybe someday in the future, I'll show about some of the architecture of how all these streaming services and databases and apps and things work. But with that, get out there, create an account on sotamate.com. Make sure you use your call sign as the username. And I'm here to help. There's on the website is the email address to send me a message or get on Slack. Slack for North America is where I hang out a lot. And give me your suggestions and bug reports. Happy to help. And this peak here is Red Lake Peak around Tahoe.